Dear all, this is a brief introduction on what we call naive Bayes. Naive Bayes. While Bayes because it's a procedure that uses Bayes theorem, while naive because it's one of the most simple procedures that use Bayes theorem. So this type of technique born in and is essentially used in problem of classification. Usually in classification, here for example, let's take a specific example. Suppose we want to classify email and if they are spam or normal email. So for each email, for example, for the first email, we observe that it is spam and the text in the email was made of these sequences of words, and very simple. No? So send your car. So the first is spam, the second is normal, the third is normal, the fourth is spam, the fifth is spam, but we want to classify this sixth email, which we don't know if it is spam or not. So first of all, let's make a setup of the problem. So in every Bayesian analysis, we have a parameter that we wish to know. Look, I denote by theta because and this is the parameter we want to estimate. So the parameter, the support of the parameter is spam versus normal. Okay, so this is a very simple as a two-state parameter. Then these are the data we observe, or in classification the future. So we will denote by x1, x2, x3, and x4. Okay. So usually in machine learning, this is denoted by y, okay? But we don't care about this because we know that this is our random parameter because here is random and we want to estimate its posterior probability based on the text. So the text we understand is made of four variables. So the first is only two, is all categorical with two categories. The first is send versus check. The second is presence of off versus not off. The third is the presence of the word your versus not the word your is not present. The fourth is key versus car. Okay, so looking at the data, for example, it is, um, uh, for example, if it is, for example, the word your and the word off may be not very useful to distinguish spam at the first sight. Because, for example, off appear in spam and normal and your also appear in spam and normal, but we have to now we make a precise calculation about how each feature can be useful for estimating theta. So first of all, the first thing in a Bayesian analysis is to set a prior on theta. Okay, usually we said, well, suppose that we know we have a prior idea about the probability of receiving spam or not. In naive Bayes, this prior probability is essentially how frequent is the word, for example, spam in this case. So the prior probability for theta is just a Bernoulli random variable, is spam with probability 3 out of 5, 3 out of 5, and is normal with probability 2 out of 5. Okay, so theta a priori is supposed to be a Bernoulli random variable with this two probability. Let's consider spam success. So the probability of theta equal 1 of success is 3 over 5. Okay. Now this is the prior. The prior is setting using the already observed data. It's a technique not very orthodox in Bayesian analysis, but sometimes this technique is referred as empirical Bayes because we use the empirical data to obtain an idea about the prior probability. But let's say that this is not very orthodox. For example, other prior could be used. For example, suppose that a priori you don't know if you are more probable to estimate to receive a spam versus normal, you could have set up, this is 1/2. You could have set 1/2 versus 1/2. Okay. Remember, in an orthodox Bayesian analysis, the prior is prior to the data, so should be not data driven. Anyway, once we have the prior, now we can set up the likelihood. So how likely is to observe, for example, the word check, so x1 equal check, given that theta is equal to spam. This likelihood now in this simple case resembles to the frequencies of word check for all spam under given all spam messages. So check spam messages are free, and we observe a check twice, here and here. So 2/3. That's the likelihood of spam if we observe the word check. Now, how likely is that the message is a spam if we observe, for example, the word send? Well, this is the contrary, is just 1/3. Okay, so in fact, we have 3 messages of spam and 1 is sent. Okay, now, so we can make a simple reasoning. So suppose now we have to apply the Bayes theorem. Suppose I observe the word check. What is the probability of being a spam? So this is the probability of theta given x1. And now here is where we use the Bayes theorem. So this probability is just the likelihood. So likelihood of check given spam for the prior probability of spam, okay, divided by the probability of the word check. Okay. Now, in this case, this number without many counts are very easy because so the likelihood of spam given check is 2/3, the prior of spam is 3/5, and the probability of check we can just look here. So check appear 3 out of 5 messages, so 3 out of 5 messages. Then the posterior probability of being a spam given that we observe the word check is 2/3. Okay, and this is our prediction of spam using only the word check or send, so only future one. So if we want to make things even more formally, we have to remember that the denominator of the Bayes theorem is the normalizing constant over the parameter space of the posterior. So we have to calculate the probability of check. The probability of check appear either on the spam, so the numerator must be one of the term in the sum, plus the check appear also for the normal. And this is so the likelihood of being a normal given check is, so let's take there are 2 normal messages, one is check, so it's 1/2 by multiplied by the prior of normal message, which is 2/5, and this gives you 3/5. Okay, so remember the normalizing constant is correspond to the integral over the parameter space. Here is the integral is resembled by sums, and the parameter space is spam theta versus normal, so it's theta negated. So up to now we used the only one word to classify the email. But suppose we want to use the entire message. So we have to calculate the posterior probability given all our future. Now, this is proportional, if you remember, of the likelihood of theta and the future, x1, x2, x3, and x4 multiplied by the prior on theta. The point is how to set up this likelihood. In naive Bayes, each future are assumed to be independent. So this likelihood here is just the product of the likelihood of each word separately. So the likelihood of theta given x1 multiply the likelihood of theta for x2 multiply the likelihood of theta for x3 multiply the likelihood of theta for x4. Each likelihood is calculated exactly as above. Okay. So each piece of the likelihood is described in this table. For example, these are the number for, we already discussed it for the word check and send under spam and not spam, and for the rest of the word. Now you can see that it seems there are not words that assure you or makes spam very likely or normal very likely. For example, the word your make normal very likely, but also spam very likely. So here, for example, if appear words that if appear the word your, the prior would play a great role in deciding if it is spam or normal. And for the rest of the word, for example, car, the only word which is can be interesting could be car. For example, if car appear, then it's very likely that the message is normal and not so likely that it's spam. So car could be a good candidate for discriminating the message. However, we will use all the words. So how likely is spam if we receive the sixth message? With the word are send off key. So x1 equals send, x2 equal off, x4 equal key, and x3 is not yours. Okay, so we have to multiply the likelihood of each of, for example, being spam given this word. So for the numerator of the Bayes formula, we need this number. So send of not your key. Okay, so the likelihood of send of key is 1/3 by 2/3, 1/3 by 2/3 by 1/3 by 2/3. So this number here is 4/81. Now, what is the likelihood of being normal? Now, it is middle to see that it's 0. 0 because the word key, if the word key appears, we never observe the normal message. So how likely is it to be normal if a case appear? Well, the likelihood is 0, so the product is 0. Now this is a terrible message, but a logical consequence of using the word as if they were independent. But in any case, this is the likelihood of being normal. So given this, whatever is the prior, we end up in saying that the posterior probability of being spam if the message is send of key, the posterior probability is 1 because the numerator is 4/81 and the denominator must be also 4/81. Now, next step is to see how to use all this in R for general purposes.